I'd like to welcome everyone to this webinar, What Will the Future of Electric Vehicles Mean for the Supply Chain?, which is sponsored by electricity and gas supplier Eon. Today I'm joined by three presenters: Simon Swann, who is the Director of Future Mobility at Arcadis; Matt Croucher, Associate Director and Electric Vehicles Lead at WSP; and Justin Savage, the Electric Vehicle Technical Sales Manager at Eon. I am Thomas Lane, the Technical Editor of Building. Last November, the government brought forward its date to ban petrol and diesel cars and vans from 2035 to 2030. This is already impacting on buying decisions. Electric vehicles were the fastest growing type in the year to January 2021, taking nearly 7% of the market compared to 2.7% the year before, which is a 54% increase. Sales of plug-in hybrids are also up. By contrast, the market share of diesel vehicles dropped 62% in a year and petrol-powered vehicles 50%. This growth in electric vehicle sales needs to be accompanied by an increase in the availability of charging points. As RAC research shows, a patchy charging network is putting people off buying electric cars. In a bid to tackle this issue, the government is now in the process of introducing new building regulations requiring new residential and non-domestic schemes to install electric charging points. This will also apply to significant refurbishments of residential and non-residential buildings too. So in this webinar today, we will discuss what are the requirements for charging points likely to be, what is involved in providing these, and what are the potential costs, what are the implications of increased electricity demand on infrastructure, and what does this mean for developers, what is the role for home electricity storage, and what is the role of PV. Once all the speakers are presented, we will then discuss the issues that their presentations raise. So it's now time for me to hand over to Simon for his presentation. Thank you, Simon.
Okay, so my name's Simon Swann. I'm Future Mobility Director at Arcadis. I've been with Arcadis about 16 years and I've got 20 years experience of managing projects and programs. In the last 6 years, we've been developing our future mobility part of the business. What does future mobility mean? It means, for us, it means anything from connected and autonomous vehicles, mobility as a service. We look at micro mobility, rise of the e-scooters, for example, and also the future of flight. So hydrogen and battery powered aircraft, for example. And I focus in the middle ground, which is electrification, and we broadly arrange our solutions for our clients around EV strategy and EV delivery. So we supply, install, maintain and operate charging infrastructure, but we also help cities and local authorities with their overarching strategies, and we help likes of Met Police and Ministry of Justice with their fleet electrification strategy as well. And so I'm going to talk about electric vehicles from a strategic perspective. Look, we've got an enormous opportunity here. We learned about global warming at school, and for me that was in the 80s while listening to the likes of Wham, for example, and it's not a reflection. My hair isn't a reflection of my music taste; it's more a reflection of COVID. This is our challenge of our generation, and by 2050, the UK will actually be net zero, and as set out by the Climate Change Committee. Over 20% of emissions are from transport, and they also contribute to nitrous oxide, particulate matter, air pollution, leading to 7 million deaths every year. And this year is quite exciting because the UK is hosting COP26, which is the UN Climate Summit. So the eyes of the world are going to be on the UK and how we're going to be leading in terms of developing a net zero economy. And the government has launched their 10-point plan for a green industrial revolution. It looks at accelerating offshore wind and nuclear power and green hydrogen and green public transport and jet zero, so the future of flight, as well as greener buildings, carbon capture. The UK will shortly be having in place a transport decarbonisation plan as well, and will be one of the first G7 economies to have such a plan. And all these plans need to be supported by policy, and policy is really, really important, but it's not the only thing. We need infrastructure, and we need a mature EV market, and the infrastructure has to be the right chargers in the right place at the right time at the right cost, and they've got to be accessible for everyone as well. And the EV market needs to be mature. We're working with the Home Office at the moment, and they don't. There's some electric vehicles that just aren't suitable for their needs. You know, for officers with all their kit and prisoners and so on and so forth. We're also working with distribution and logistics companies, and they're trialling 40-ton battery electric vehicle, as well as hydrogen fuel cells and compressed natural gas as well. And so they're trialing all of these new types of vehicles, but I still can't get an affordable electric 7-seater. So the market is getting there, but it's not there yet. The infrastructure is growing all the time, and I'll go into that in a bit more detail in a sec, as will Justin and Matt. So just a bit of a deeper dive on EV policy. So there is going to be a ban on new petrol and diesel cars by 2030. Between 2030 and 2035, there'll be you'll only be able to buy plug-in hybrids, for example, but all vehicles will be zero emission by 2050. At least that's the aim. The government's doing a whole raft of things. There's another 2.8 billion of funding that's been made available, and that's to fund new schemes like the on-street residential charge point scheme, for example. We're going to see an expansion of low emission zones, and already in London there's going to be an extension to the ultra low emission zone, and we're going to see an introduction to zero emission zones in some cities over the next few years as well. And of course, the building regulations, there was a consultation in 2019, and I'll go into a little bit of detail on some of that. But look, policy must encourage take up for all EV drivers. 1 in 5 people in the UK are disabled, and there's no policy at the moment for accommodating their needs. So when we're designing infrastructure and layouts for charge points, for example, we need to take that into consideration. So what more can be done in terms of policy? There's disproportionate distribution across the UK at the moment. There's not enough infrastructure in some of the rural or poor areas. So what could be done? Well, we could procure charge points through tenders with very long contract terms and guaranteed revenue for charge point operators. Local authorities are woefully underfunded in some places, and so therefore they haven't had the resources to be able to apply for some of the grants, for example, to be able to install charge points in their areas. So the government could fund charge point teams, for example. The new grid connections are really expensive. So on the motorway service areas, for example, we're going to need between 8 and 10 megawatts of power for cars and vans, and probably another 10 megawatts of power for when all of the HGVs are electric as well. So it's really expensive. So the government could tender the high power charging points and strategic grid locations. And look, we don't like many apps. We need to make sure that there's interoperability for all the charge points. And there's nothing worse than turning up to a charge point that's not working. So customer experience is key. So all charge points need to be at least funded with government money, must be meeting minimum service level requirements, and to be fully interoperable as well. Currently there are local monopolies in terms of charge point operators, and that could lead to excessive pricing. So we could see the government regulating the price. And how about a ban on petrol and diesel HGVs, and a ban on internal combustion engine buses as well. So just a quick few points on the building regs. Broadly split between residential buildings and non-residential buildings. Every new building with car parking is going to need to have a charge point installed, and for those residential buildings with more than 10 spaces, then cable routes installed as well. Every building undergoing a major renovation with more than 10 parking spaces is going to need to have cable routes to electric vehicle charge points in every car parking space as well. And for non-residential buildings, every new building and every building undergoing a major renovation with more than 10 car parking spaces to have one charge point and cable routes for a charge point for 1 in 5 spaces. And there's also a requirement for existing buildings with more than 20 car parking spaces to have at least one charge point from 2025. And what type of charge point? 7 kilowatts is what's being specified at the moment. There's going to be exemptions, of course, for builders and the supply chain where this is just too expensive. So that will need to be worked out as well in terms of the cost cap. So there are potential impacts across many different types of businesses, whether you're an EV business, a housing developer, a distribution company, or a placemaking. And we could go into that in a bit more detail, but standardized approach for EV businesses would be a good thing. Future-proofing for housing businesses, it would be a good thing. But of course, there's going to be additional complexity and additional build costs associated with all of this charging infrastructure. Just wary of the time. I'm going to keep going into, for a couple more minutes. There's a number of funding and grant schemes, funding routes and grant schemes available, including the home charge scheme. There's a workplace charging scheme as well. And if you go on to the Office of Zero Emission Vehicles, you can find out more about these grants that would be available to you. In terms of the market, we heard Thomas talk around the number of battery electric vehicles that are being sold now. COVID has had a huge impact to the car industry. January was the worst year since 1970. But the number of available EV models has almost doubled from 22 to 40 this year, which is fantastic news. The battery electric vehicle uptake grew as well by 54%. I think just Thomas mentioned that. And new emission figures show that 2020 was the year that delivered the cleanest vehicles in history, as average CO2 emissions fell as well on the previous year. So more than half of all battery electric vehicles registered in the past 2 decades were registered in 2020 alone, which is amazing. And there's more EV choice now in the market, and in fact 1 in 6 new cars is now an EV. In terms of the infrastructure in the UK, there's nearly 21,000 public electric vehicle charging devices now, and nearly 4,000 rapid chargers, and that's growing all the time. Rapid chargers are 50 kilowatts, and they could charge depending on the size of the battery in the car, but they could charge a typical car in about 30 minutes to about 80% charge. But there is uneven distribution across the UK, in particular the northeast and northwest, for example. And there's a number of different reasons for that. I touched on that previously, but access to funding. Some local authorities have found it difficult to resource the application process, and a lot of it's been market-led as well. So we'll need to see policies brought in to address that. But the size of the prize, the size of the challenge is enormous ahead of us. We think that there could be 1.5 million chargers needed to be installed by 2030, and nearly 3 million by 2035. So yeah, massive challenge. But look, 20% of all carbon emissions from electric vehicles. So if we get this right, we're going to make a big impact as we head towards that 2050 target of being net zero. Okay, well that's me. I've probably talked far too long, and apologies for that. I'll hand back to Thomas.
Great. Well, thank you very much indeed, Simon, for a really interesting presentation. Just before we go over to Matt, I was just intrigued to know, is this sort of very uneven distribution of charging infrastructure being provided by local authorities? I mean, what is the blocker? Is it the case they haven't got enough money, or that the application process is difficult, or is the money, can they get money and spend it on other things? Is it ring fenced?
Yeah, I think there's I think the money is available. It's just not all of the local authorities have been trying to access it. So I think it does come down to the availability of resources within that local authority, and to be able to pay, if they want to pay consultants to apply for that funding on their behalf. Of course, that's going to cost money as well. So predominantly, I think it's largely down to that.
Right, I see. I mean, I guess that so it's really a case of having the people in the local authority that are dedicated to doing that might help.
Yeah.
I mean, and now a quick question. I mean, I think something like nearly 3/4 of local authorities have declared climate emergencies and got very ambitious targets to be net zero. I mean, is this driving them in any way towards maybe speeding this up a bit?
Yeah, I think it is. I think absolutely. They look at their own fleets. A lot of the councils have their own fleet of vehicles as well, and by transitioning their existing fleet of vehicles and enabling other businesses within their local areas to transition their vehicles over to an electric fleet will definitely help towards their net zero targets as well.
Great. Well, thanks very much. It's probably a subject we'll return to later on. But anyway, so I'd like to hand over now to Matt Croucher from WSP, who's going to talk about infrastructure.
Okay, well, morning everyone, and thanks for having me on the panel today. Been looking forward to this. Very interesting topic area, and I'm sure we'll have some good discussions around this. So just by way of brief introduction for those who don't know, my name's Matt Croucher. I'm the Zero Emission Mobility Lead at WSP within our Future Mobility team. And WSP is a global planning and engineering consultancy. My background particularly is transport planning. I've been working in the EV space for 10 years now. It's come a long way over that point to what we kind of see today. And I work with colleagues across all the different disciplines which we cover within WSP, ranging from the planning side to the grid and power, to the electrical engineers and to the highways engineers, and across the full breadth. Working with the likes of the World Bank, Department for Transport, local authorities, property managers, and investors, providing due diligence support and so on. So a very broad work area, and it really does necessitate a kind of broad input across the full spectrum of disciplines. So my background is transport planning, so that's kind of the lens I look through. Right, I'm just going to start going through the presentation. So there's a little bit of overlap in places with what Simon's covered, so I'll try and skip through those bits, but I just wanted to set the scene, I suppose, within what I was going to say as well. So that's where a little bit of overlap comes in. So a little bit hard to avoid stating the obvious that it's been a fairly remarkable year or so in many respects, what with COVID and all the economic fallout that's come with that. Yet, despite everything, EV uptake has continued to accelerate, and we've heard some of the stats already around that, so I won't dwell on the specifics, but I guess I just wanted to emphasize that we have seen this marked uptick despite all of the conditions facing the wider automotive sector. And we'd already been seeing good growth for quite a number of years now, typically of the order shown there from 2.5% market share of new vehicle sales in 2018 to 3% in 2019. I mean, that's reasonable kind of year-on-year growth rate there, but then a leap to over 10% in 2020. and in chart form, you can see that over the past couple of years in particular, we're seeing a real uptick in sales. And the blue line, the lighter blue line there being the pure battery electric vehicles having overtaken plug-in hybrid electric vehicles, PHEVs, over the past couple of years in absolute sales as well is another kind of notable trend that we've seen. And various reasons for this. In part, we're seeing certainly a kind of growing impetus with all the talk of green recoveries and building back better. We've had the 10-point plan published at the end of last year with looking to a green industrial revolution, and as some of the points we've already seen covered around that involving bringing forward the ban on petrol diesel vehicles to 2030. So as compared to a few years ago when it's far less of a, I guess, a foregone conclusion, very much now EVs are widely accepted as being a key part of the solution when it comes to climate change, and are firmly baked into future policies. The 2030 ban just serves to accelerate a trend that was already happening, and it brings the UK into line with a number of other European countries. We've also got Norway going a bit faster, as they have been for quite some time, and they're phasing out their internal combustion engine cars from 2025. So tweaks to policy like this are significant and do have a bearing on the number of vehicles on the road in future years, and how quickly that's going to happen, and in turn what the infrastructure requirements are going to be around that. So we've seen some of the forecasts and reports published shortly after or just before the announcement of the ban, projecting a 20% increase in low emission vehicle sales in 2030. Relative to what there would have been with a 2035 ban. So 20% increase is a significant increase in the number of vehicles on the road that are going to require charging infrastructure sooner. Also has implications for the role of alternative low emission fuels like hydrogen. Another key reason for this rapid kind of uptick in EV sales, as Simon touched on, is in part the kind of significant increase in the range of models available, and the increasing range and performance of those vehicles that are available. So across an increasing number of segments, there is an electric or hybrid option now, and that's opening up new sales. Other key kind of factors driving growth, we're seeing the continuing falling costs, and we're still on track for the expectation of price parity, so upfront purchase price parity with conventionally fueled vehicles by around 2025. And a big part of that, as you can see in the figure there, is the battery costs are falling steadily and are projected to continue to fall, not quite as rapidly as they have been, but still significant. We've also seen a strong array of incentives in terms of funding for chargers for at home and elsewhere, but also things like the reduction of benefit in kind tax to 0% initially and now 1%, which delivers significant savings to the user. And given the proportion of cars that are sold through a leased company car scheme segment, that's been particularly effective. So what does all this mean? So in terms of charging infrastructure to support EVs, it's probably shouldn't be understated really, and I think everyone on the call probably appreciates that it's a fairly huge undertaking to transition from what we've got here. It's a very established internal combustion engine refueling network, a very kind of optimized and efficient network, to a fundamentally different way of charging of vehicles, where there are different options. So more places in principle are available to charge. Electricity is far more widely available, obviously, than a petrol station. But it comes with different considerations around charge rates and supply capacities. And there's some of those different charge point types that I've just covered within this figure here, ranging from the humble domestic socket, which isn't really suitable for kind of regular intensive use, but certainly as an option for an occasional stop as a visitor somewhere is very welcome. Range through from a standard or a fast charger, which are more than adequate in most instances, and then rapid through to ultra rapid chargers for intermediate type locations. As Simon's touched on, so I won't dwell on this, the number of charge points available across the UK has increased rapidly, along with the trend in increasing vehicle numbers over the past 10 years. It is very spatially uneven, as Simon mentioned, and you can see within the chart here that we're seeing an increasing proportion of rapid and ultra rapid chargers coming into that mix over more recent years as well. So some key points I guess I want to get across in this short presentation are just around right sizing the charging infrastructure, and when we come to thinking about what infrastructure requirements are for EVs, a key point to consider is around charging behaviours, and some of those factors include location, the type of location, the dwell time, and the charge point availability. But also the vehicle capability is a point that's often overlooked. So across those range of different charge point types we just featured on the previous page, if we take, for example, a Nissan Leaf, this is just what I've got. This is the best-selling car in the UK to date, a pure battery electric vehicle. Of these different charging types, it can only actually support the slow charge, a standard charge, but only up to 6.6 kilowatts. And it can support a rapid charge at 50 kilowatts. It can't support three-phase AC charging at up to 22 kilowatts. Some can, Zoe, Tesla, but not all. And it doesn't support ultra-rapid charges over 50 kilowatts. So there's important kind of considerations to bear in mind when planning for EV infrastructure provision is what the infrastructure you put in can actually support, what the vehicles can take from that. And here we see a figure just demonstrating the range of maximum charge rates that vehicles can accept, and you can see that until recently, typically 50 kilowatts was the ceiling, and some lower than that, certainly hybrids and some of the older vehicles. And at the moment, it's only very few and the premium supercar type models like the Porsche Taycan that can support charge rates up to 270 kilowatt hours. The other thing to consider is what you really need in a location, and this comes back often to dwell time. And our vehicles are parked for a huge proportion of the time inactive, something like 96% of the time, depending on what statistic you look at. So there's often quite significant opportunity to charge where you'd already parked them and where they're inactive for long periods of time, and that's at home for the large part. So something like 90% of recharges and 75% of electricity consumption currently takes place at home. And we're expecting that to change a bit as the proportion of vehicles which don't have access to off-street parking increases. But fundamentally, that ratio we would expect to see similarly weighted in that direction. In terms of charge point deployment formats is another one to consider. So charge points can be deployed in a variety of ways, and depending again on the land use and the use case of the individuals you're trying to cater to. So for example, you've got something like destination chargers in a supermarket car park as an example. So it's a place people want to go, it's a place people would be going to anyway, it's their destination. And so you're catering for them there, and then it's really a case of understanding how long they're going to be there, whether they would want to charge that kind of location. If so, how do you make that appealing and convenient to them? Other models, such as a rapid hub, is really more akin than to a petrol station, where people are stopping off there on their way to somewhere else. So it's kind of fundamentally different model. And there's a whole host of other options here that I won't go through now. So context is key, is a point we tend to advise our clients on this. So whether they're looking at electrifying their estate, be that kind of workplaces, shopping centres, or residential complexes or estates, it's fundamental to understand what the use case of either the customers, the employees, the residents, or fleet and operational service vehicles is. So they'll have differing dwell times, different turnaround requirements that will, in some instances, require higher powered charges, often not, but it's again important to understand what those requirements are. And then there's a differing willingness to pay and requirements for access to those charges as well, which then entail different requirements for the charges in terms of managing the sites. The other thing that's important to understand and is often overlooked is actually understanding the stakeholder objectives and what they want from the charge point deployment. So sometimes it's a case of just adding value for their existing customers, so they may not intend to charge for the use of the charge points, or if so, only at a kind of break-even rate. It may be as a new revenue stream, so specifically to generate revenue, in which case it's a very different model. It might be the case of for residents or employees. So in each instance, the host will have a different set of objectives that they're seeking to achieve, and again, that would inform what you'd want to install and how you'd manage that. There's also the attitude to risk and to what extent, if it's a commercial proposition, you're happy to take on that utilization risk or not. Last couple of slides from me, so I'm conscious of time. Some key considerations for planning and deployment of charging infrastructure are scalability and future-proofing. So by scalability, what we mean is ensuring that additional charge points can be added in the future. At the moment, we're something like 1% of vehicles in the UK are electric vehicles. So at the moment, the requirement is very low. It doesn't make sense to over-provide beyond a certain point for that at the moment. So it's about ensuring that what a deployment goes in today is scalable and can be expanded on tomorrow. So ideally looking at least 2 or 3 years ahead, and ideally kind of 5 years ahead, really. So you've kind of got that future scope to expand. And it's important, therefore, that the first charge points you put in, whilst it can be easy to put in something that's cheaper today, if you lock yourself out of being able to expand that in tomorrow, you potentially kind of land yourself with quite an expensive cost in replacing and removing some of those. And some other key features are load management. So this comes in 2 varieties: the static load management, which is a fairly simplistic one where you just divide the incoming supply by the number of charges. They've got equal provision of charge rate. Dynamic load management enables a far more optimized use of the available incoming supply. So it means that you're allowing differential charge rates for each of the vehicles. You can maximize the charge rate for the vehicles who are charging, knowing that the others aren't in use, for example, and that's often the case with EVs. So you get a lot of extra capacity and efficiencies through this model. It can reduce the load by around 2/3 relative to a static load managed installation. Final point is then just passive charging provision. So this is where you put in that enabling infrastructure, as Simon talked about, and is baked into the updated building regs as a ready means of expanding future charge points. I did have a slide on the updated building regs as well, but I'll skip over this because I'm conscious of time, and Simon's covered this already. And the final point I was going to make was just around delivery models, and just very briefly, these can come in a variety of forms. So ranging from a conventional kind of just upfront purchase of the kit, potentially for a finance agreement, but one way or the other, it's just a simple own and operate model, straight through to things like a concessionary model, which is popular amongst local authorities, where it's a kind of public-private model where you lever in some private sector investment, but enable the public sector to retain a good amount of control and profit share and to dictate some terms, through to a fully funded type model where a private investor would come in. They'll take the utilization risk, they'll install the charge points at their own cost, but then take the majority of the revenues that come from that, and they'll obviously only really be interested in sites where there's a good prospect of commercial returns. Right, so I've whizzed through that quite quickly. I've probably talked far too long, so I hope that was interesting, and yeah, I'll hand back to Thomas.
Great, well, thanks very much, Matt. Just one very quick question, just to pick up on one of your points, is it's quite interesting to see that not all electric cars are created equal when it comes to ability to charge fast. I mean, is that something? I mean, why is that? And is that something that will be addressed in the near future? So whatever car you buy, you can charge it any way you want.
Yeah, it's a good question. So, I mean, part of it relates to just kind of the age of the vehicles and when they were launched. So, for example, the Nissan Leaf has been out for a number of years now, and when it came out, ultra rapid chargers it didn't really exist in any significant way. So, 50 kilowatt charger was a sensible kind of maximum charge rate for that vehicle to accept. But as the technologies are improving and the charging technology rolls out, the vehicle, the OEMs are equally producing vehicles that can support ever higher charge rates, in part because the batteries are larger, and so if you want to charge it up to 80%, you need a higher charge rate to be able to do it within that same time period. And it's public demand, is what people want, is to get that higher charge rate. I do think it will kind of level off at a certain point because it starts to get very expensive to have very high power ultra rapid charges, and for the vehicle to be able to handle those. But yeah, I think we'll continue to see that grow for a little while yet.
Great. Well, thanks very much, Matt. So without further ado, I'd like to hand over to Justin Savage, who is the EV the technical sales manager at Eon. So thanks very much, Justin.
Hi there, everybody. And as Thomas said earlier, I'm having some technical difficulty, so you'll only be able to hear me and not see me, which is probably a good thing, given the lockdown haircut situation. Anyway, thank you for your time and for joining me today. I'm Justin Savage, Eon's EV technical sales manager. I've been at Eon for about 3 years now, previously their UK account manager for solar and storage in the developer space. And I'd like to share our vision and views with you about the EV landscape, what challenges are due to happen in your industries, and how this could affect what you're going to be having to do moving forward. So without further ado, let's start. Excellent. So the Paris Agreement in 2015 was a game-changing moment. 196 countries, including the United States, committed to limiting global warming to just 1.5 to 2 degrees Celsius above pre-industrial levels. What came from that commitment was not only cross-country collaboration, new policies, but also hard cash. Since then, the UK government has made its own legally binding target to cut its greenhouse gas emissions to net zero by 2050. This is something that we're all three of us have mentioned. I think the more that something's mentioned, or the more repetitive it is, it's just clear that it's going to be one of the biggest factors. So, in fact, at local level, we've seen local authorities declare climate change emergencies, with many aiming to be net zero by 2030. Of course, transport remains the highest polluted sector, and driven by the Paris Agreement, the UK government launched the Road to Zero strategy, a strategy to achieve net zero carbon transport emissions by 2030. A number of levers form part of that strategy: clean air zones, building regulations, zero benefit in kind tax rates, grants, and more grants. But of course, the biggest lever of them all is the ban on new sales of petrol and diesel vehicles. And now, in the midst of a global pandemic, when consumers are more environmentally conscious than they've ever been before, we find the eyes of the world on a different city, this time on Glasgow, which hosts the UN Climate Change Conference of Parties. When the world leaders gather in Glasgow in November of this year, the need to deal with climate change is even more urgent, if for no other reason than as a source of economic growth. The question, though, is not can we maintain the Paris Agreement, not can we match their vision, but can we go one step further? The next slide. With this at the forefront of all that Eon does, we have set our own targets. We will have electrified our own fleet by 2030. In the UK, we began that journey over 12 months ago by converting our company car policy to battery electric only, so that within 3 years' time, all of our company cars will be electric. For those cash allowance drivers and our entire workforce, we have just launched a BEV salary sacrifice scheme, enabling our people and their friends and family to drive an electric car, benefiting from tax savings whilst reducing their impact on the environment. So, like commercial vans remain a challenge, but we are committed to electrifying our entire LCV fleet by 2026. We're undertaking a trial with those vans to work out the impacts from our customer, colleague, and commercial perspective, including vehicle to grid and time of use charging. And of course, we're an active member of EV100, a group of large fleet operators who have all committed to electrifying their fleets. To help the transition to EV, we've got EV charging at the majority of our sites. As you can see from the picture on the slide, that's our Newstead office with our EV chargers, and that enables our drivers to charge at home and also at work. As you'd expect, the electricity supply is all 100% renewable too. So next slide. For the rest of the UK who aren't EV experts, what steps are required to actually hit and then exceed the targets set for us without leaving the UK in a transport dilemma of mammoth proportions? Whilst it's clear that EV is here to stay as a technology because we've either taken the plunge ourselves or because of published facts and figures that support as much, many still wonder how realistic it is to think we will be where we need to be in less than 10 years' time. It's a bit chicken and egg, isn't it? So do you buy the car without the infrastructure to support the obvious demand, or do you hold off? Clearly, the UK needs to invest heavily in the number and the accessibility of charge points. Given that currently over 60% of charging will be done at home, that's a figure that I think is going to rise significantly as time goes by. And with work habits changing due to COVID-19, it looks like this will not only increase over time, it stands to reason that the new build developer market, which I focus in within my role heavily, will be a core area to focus on. In fact, Eon are expecting an already delayed government announcement later in 2021, making it a building regulation requirement for all new properties to have charge points in some capacity or another. We see it being it's actually going a step further than this. In actual fact, we think, as has already been said before, a minimum rating of 7 kilowatts will be required on all plots, and to cope with the increased demand on the grid, smart charging technology will be essential. This will allow DNOs and IDNOs to no longer rely on worst case calculations when providing capacity to development, but instead lean on companies like ourselves who have their own e-mobility platforms and smart grid applications to manage this on their behalf. So GOM will be the cable in the ground solution that many developers are currently getting away with. GOM will also be the 3-pin plug option that charges your car in days, not hours. And GOM will be the high level of ambiguity that planning conditions currently offer. This is progress. The truth is, though, that until the announcement happens and is out in the public domain, we can only make educated guesses. But what I can say is we're not going to be a million miles off that. I'm certain of that. Next slide. So as my role at Eon is predominantly in a sales capacity, it would be a missed opportunity not to highlight where Eon have a solution to a problem or where we might lead the pack. So many see Eon as an infrastructure business, an energy supplier, and possibly until now had no idea we were also an EV manufacturer, installer, and operator. Add to this that we were one of the first companies to supply 100% renewable electricity to our customers, and the picture starts to paint itself. Eon are actually one of the world's largest investor-owned electric utility service providers, which is a bit of a mouthful, but we are perfectly placed to provide solutions for EV, smart grid, and the electrification of heat when it arrives in 2025. As you can clearly see from this graphic, we offer a truly end-to-end in-house solution for our clients and their customers too. Next slide. So regarding EV for the new build space, which as I said earlier is my focus, Eon have a number of passive and active AC charging solutions that are packaged specifically for UK developers. These are labelled on here as the entry and the advanced units. I've been heavily involved in bringing this particular range to market, and I've had a bit more time than I would have normally had due to lockdown and various things going on last year. But what I can say is that we can provide this on a supply-only basis, so it keeps the costs for developers to a minimum. It eliminates the crossover of trades on site. What's more, because our product is modular, our passive solution is around a third of the price of what our direct competitors are currently able to offer. So it ticks a box with current planning conditions, We believe that it will tick a box with future building regulations, and it's fully smart. So we're finding that our current client base are not being charged by their DNOs or IDNOs for increases in capacity in the same regard as if they were going for the 3-pin plugs or other scenarios. Our price for this extremely popular passive solution, which is called eClick, is just £150 per plot. I'm not going to plug it any more than that on here, but I am happy to take your interest offline regarding this. So next slide. Pictured here is our Eon Drive Booster. This provides up to 150 kilowatts of charge per user, but only requires a 40 kilowatt grid connection. What this means is that it makes it possible to connect something much more powerful than you would normally get by utilizing its internal battery. This solution is ideal for locations where EV is a mandatory requirement, but where grid costs are prohibitive. And we're seeing this product requested in urban locations, limited space locations, and also temporary locations because of the fact that it can be relocated very easily. We also have a unique smart grid solution for developers which monitors energy usage in real time at site level. DNOs are already accepting this as an alternative solution to expensive upgrade charges, which is saving our clients, in some cases, 7-figure sums, which that's not a typo, that's not me saying it wrong, 7-figure sums. That's a game changer in itself. So if we're brought in at phase 1 of a development, we can reduce the risk of upgrade charges being added at future stages of that development and future phases. I guess the ultimate point I'm trying to make here is that there's plenty to be excited about, especially if you're a client of Eons. Next slide. So thanks very much for your time.
Great. Well, thanks very much indeed, Justin. We haven't got an awful lot of time left, sadly. There's only about 10 minutes for questions, but there's plenty of those coming in. Anyway, the first question I've got really is for Justin and maybe for his colleague, actually, Ryan Smith, who is Eon's Technical Operations Manager, who Justin might want to defer that to. But I guess one of the issues is all this, thinking about people's homes, a 7-kilowatt charger for charging your EV, but also thinking about the ban on fossil fuel fired boilers from 2025 means that a lot of people are going to be driven towards using electric heat pumps in the home, which really is going to bump up the electrical demand from individual homes. So I guess there's 2 strands of this question. Firstly, what is the impact on the kind of domestic wiring in each home? And does it mean that it's all going to have to be completely different, much thicker wires everywhere? And secondly, I understand that there are sort of smart solutions, but at the end of the day, homes are going to be drawing an awful lot more power than they did in the past. So what impact is this going to have on infrastructure? And I'm thinking about things like power supply to individual sites, substations, and people are going to have to start putting in substations where they might not have had to do that before, and adding to the cost of development.
Sure. Well, I can certainly answer a couple of those points, Thomas. With regards to the impact on the cost of connection for each of the properties, clearly when you're starting to then look at adding heat pumps, the load is going to increase. There's no way around that. So the inclusion of PV on a per plot basis is going to offset that slightly, I guess. The smart grid solution that I mentioned in my slides, which up until now, I'm told, well, it's been called PD Hero, Property Developer Hero. I've been told there is a new name for it, but I've not been told what that name is. So at the moment, it's called PD Hero. And what that basically does is at a site level, it will allow us to monitor all of the assets on a development, such as your heat pumps, such as your EV chargers, your PV arrays, and we can then distribute all of the energy around that site, almost with the blessing, I guess, of the IDNO or the DNO. So we have an example of that where we're talking about this 7-figure sum. We've been able to go to a developer in Scotland where they got to phase 2 of their development, and suddenly they were told by Scottish Power, I think it was, there is no more capacity. The buck stops here. It's going to cost you an awful lot to to do what you want to do. So our solution was offered, it was accepted by the DNO, and it hasn't just reduced, it's almost eliminated the upgrade cost that was going to be put on the developer, which is a massive thing for us to be able to do. That's available now, but we do see it becoming more and more prevalent as heat pumps become what we think is going to be the standard or the norm from 2025 onwards. We are also seeing in certain parts of the country, particularly with Western Power, that they're starting to put three-phase in as standard on developments, which I'm personally amazed at, but it's happening. So three-phase into a development to each individual house is their way of combating that. But equally, we are seeing the smart grid solution that we're offering being a way of being able to offer that to not just Western Power regions, but other areas of the UK.
Great.
Does that answer in some way, shape, or form what you were hoping?
It does, and it's kind of reassuring to know that that you are sort of helping to address that. And obviously, Western Power, it seems like they must be putting the extra cost of three-phase installation, but if they're doing that, that's great. I've got a sort of slightly, completely other end of the spectrum. I've got quite a big sort of strategic question. I mean, someone's touched on this from some of the questions that are coming in, but with the adoption of EVs, that means that less people are driving around in diesel and petrol cars, which means that tax revenues are going to really drop off to the exchequer. So I mean, I guess the first question would be, how are they going to recover that money? And if it was to go to road pricing, which seems to be perhaps complex, but maybe an obvious solution to replace those revenues, could that have an impact on the mileage people drive? Could actually people drive a lot less, which could have a corresponding impact on the infrastructure? I don't know if maybe Simon, you want to take that one?
Yeah, sure. So I don't have an exact answer at the moment, but in terms of road pricing, I think that we will see an increase of road tolls, basically, and especially for the use of the new roads as and when they're built. But look, I mean, the general consensus is that we want to reduce the number of people driving vehicles as well as moving them to electric vehicles, zero emission vehicles. So you know, there's going to be a huge promotion of active travel. So I think people will be driving cars less in the future, and there's going to be a huge promotion of car sharing schemes as well. Now, I recognise that that doesn't necessarily plug the gap in terms of tax, and I'm not too sure what the answer is there on that. But I do think that we will see a decline of the personal car. I think we will see more active travel promoted, and we'll see an increase in the ban of petrol and diesel cars being used in our cities in the short term, and then predominantly the use of the personal car in cities, regardless of whether they're electric or not, and the promotion of car sharing. Okay.
Great, thank you, Simon. I mean, anyone else want to come in? Otherwise, I can move on to another question.
I'd agree with that. I think road user pricing is what people are certainly looking to, isn't it? And that comes with challenges, but also benefits if it does serve as a greater disincentive to private car travel. It's it's a separate issue that we've been trying to address for quite a number of years. Whether it plugs the gap entirely, I guess, depends what they charge. What's politically deliverable is probably a big component of that as well. So yeah, should be interesting.
Okay, great. Well, we've got time for one more question, I think. Quite a few people are asking about sort of other technologies. So, I mean, one person was asking about hydrogen fuel cells rather than sort of electric batteries, but another one, which I guess is allied to this, is advances in battery technology. I mean, are we going to see, you know, better batteries, ones that are lighter, greater capacity, faster charging ability? What's your views on that? Matt?
Yeah, I'm not a kind of expert in battery chemistry, and once you get down into the real details of it, it's a very kind of particular specialism. But certainly, my understanding is that there's been a lot of talk for some time about solid state batteries, for example, as being the real kind of game changer. It seems to have some discussion about that seems to have retreated back a little bit. To the point where I think they're generally viewed as being maybe kind of applied to kind of premium vehicles and to very particular use cases, because at the moment at least the costs are high. But we've seen this kind of cycle play out once before with the batteries we've got today, in that with volume production comes price falls. So I think there's an expectation that we'll continue to see improvements with the kind of established battery chemistries we've got, increasing range, reducing costs. But whether that real step change, such as solid state batteries or alternative, comes in and when is less certain at the moment. I think it definitely will. It's a case of how widely those technologies will be applied, and whether it's to all vehicles or whether it remains the preserve of kind of, you know, more sporty numbers and things like that.
Great, thank you. Would anyone else like to comment on this question?
Yeah, it's Simon. Yeah, I will. In terms of the alternative technologies, you know, hydrogen isn't going away. We're only going to see an increase in the amount of vehicles using hydrogen over the long term, not necessarily short to medium term, because all the investment at the moment is in battery electric vehicle technology. But I think for buses and aircraft and the heavier HGVs, hydrogen will play a part in that future. But in terms of the battery, the batteries being developed for cars and vans, the range will increase, and we're likely to see between 200 and 500 miles range of batteries over the next 10 years, and certainly up to 200, 300 miles in the next 5 years. But you've got to remember that the average distance people drive on a daily basis is 21 miles. Okay, so really is a much point in going any further than that. Yet we could see batteries charging quicker, but I don't think necessarily the range of the batteries will increase much beyond 300-400 miles, something like that. Okay.
Thanks very much. Well, I'm afraid we're out of time. I mean, there's so many questions coming in, and we could talk about this all day. It's a really interesting topic, but we've got to draw it to a close here. So I'd just like to say thanks very much to all our speakers for their time. It's been really interesting. And just to our audience out there, this webinar will be available as a download shortly, and if you want to see it again, you can. Thanks very much to everybody. Goodbye.